Hey, what's up, guys? Tonight's topic is what's the weather like in space? A new mission seeks to find out. Well, ESA is launching a solar mission that could help forecast potentially catastrophic events. On the morning of 1st September 1859, the English astronomer Richard Carrington noticed something strange on the surface of the Sun. Two patches of intensely white light erupting from a cluster of dark sunspots. 5 minutes later, they vanished. Later that night, bright aurora lit the Earth's sky as far south as Havana and Honolulu. Around the world, telegraph communications failed, some of them bursting into flames. Carrington had observed 1 billion tons of plasma being lifted off the Sun's surface and accelerated into space at more than 1,300 times the speed of sound. Why must such events miss the Earth? This was a direct hit. The so-called Carrington event created the largest geomagnetic storm in recorded history. Solar activity of this magnitude is thankfully rare. Analysis of ice core samples suggests the storm of 1859 may have been the fiercest in 500 years. But what if it were to happen again? The impact on today's far more technology-dependent society could be more serious. That's why governments around the world pay increasing attention to space weather. Not to be confused with weather on Earth. Space weather is concerned with the environmental conditions in near-Earth space caused by magnetic fields, radiation, and matter ejected from the Sun. Last month, the U.S. House Science, Space and Technology Committee approved a bill to prioritize investment in space weather forecasting, while the UK government has also developed a detailed strategy to prepare for serious space weather. But there is a lot we don't yet know. It's difficult to predict space weather events with accuracy, and with more than 160 years of technological advancement since the Carrington event. There's no way to know what the impact of modern society will be. To help answer this question, we need to take a closer look at the source of space weather, the Sun. In 2018, the NASA launched the Parker Solar Probe, venturing closer than any previous mission to study the Sun's atmosphere or corona. On 9 February, the European Space Agency will launch its own mission, the Solar Orbiter, that further expand our knowledge of the Sun and space weather. It will use the gravity of Venus to help it get into orbit around the Sun. The Solar Orbiter will not get as close as NASA probe, but will be able to look directly at the Sun. Of the many innovations on board the Solar Orbiter, one of the most interesting is the heat shield. Its outermost layer will be lined with a material called solar black, a type of black calcium phosphate processed from burnt bone charcoal. But churned bone has an ancient legacy. Our prehistoric ancestors would use it along with wood charcoal as a black pigment. The survival of some cave paintings after thousands of years a testament to the material's endurance. Remote sensing instruments on board the Solar Orbiter will observe the Sun through tiny sliding doors in a shield, while other instruments will measure the conditions around the spacecraft. Together, they will allow the craft to investigate the three most common types of solar activity that drive space weather. Well, solar flares. Solar flares are sudden flashes of increased brightness, but most of their energy invisible to the naked eye, consisting of intense bursts of ultraviolet and X-ray radiations. If direct on the Earth, solar flares disrupt radiant communications. The X-rays can also hit the outer atmosphere, causing low-orbiting satellites to lose altitude. Solar flares are particular concern for human missions to the Moon, Mars or beyond. For example, if Apollo 17 has launched just a few moments earlier, it may have encountered a solar storm of August 1972, potentially exposing the 3 astronauts to the dangerous levels of radiations. Scientists have a good idea of how solar flares get their energy, and we know that they occur near sunspots, but the underlying mechanisms are not well understood and current methods of flare prediction are limited. There is currently no way of knowing when any given region of the Sun will produce a flare. Solar energy particles, much like a giant particle accelerator to the Sun, sometimes shoots off storms of high-energy protons and electrons into space. The solar energetic particles can reach the Earth within an hour, penetrating the protective layers of our magnetic field and sometimes even reaching the surface. If they were to strike the Earth, electronics on board planes would be damaged and air travelers would be exposed to increased doses of radiations. Coronal mass ejections. Perhaps the most concerning element of solar activity, coronal mass ejections are eruptions on the surface of the Sun that cause large part of the corona to blast away. They are slower than solar flares or energetic particles, taking between 1 and 4 days to reach Earth, but when they do, they create two geomagnetic storms which, much like spring, compresses one side of the Earth's magnetosphere while extending the other. When the spring adjusts, his tension is directed back into the upper atmosphere. Coronal mass ejections can produce mass power outages and failure of telecommunications service, including GPS. The insurance market Lloyd of London estimates that in worst case scenario, it could leave 20 to 40 million people in the northeastern US without power, perhaps for years. Each of these phenomena can occur in isolation or in combination. On that morning in 1859, Carrington observed fall tree, a perfect solar storm. What are chances it could happen again? The estimates vary. Some reports have suggested the likelihood may be as high as 12% in the next decade. However, more recent studies have put forward a more conservative estimate of between 0.46% and 1.88%. In the range of global risk, weather in space may be considered less of the 3 to 2 hours affected than the weather on Earth. Nevertheless, the importance of ESA solar orbiter is not to be underestimated. It will answer important questions that will help us not only to prepare for severe space weather but also better understand the Sun and its impact on our life. In this article, we have a small favor to ask. Millions are turning to The Guardian for open, independent quality news every day, and readers in 180 countries around the world now support us financially. Okay. And, well, this article was amended on 20 February 2020 to remove an inaccurate reference to the speed at which solar energy particles travel. And so, that is so topic. And I see you the next episode, guys. Good night.